Right, this time we've got a voiceover, slightly different principle because it's such a big project. There's absolutely no way I've been doing this without the radio on, some music in the background. So I'm afraid with no sound effects, but I'm going to talk through each of the processes as you see it on screen, and so I'll give you an idea of what we're doing. So we started off this time, the main billet for the hub, and it is 100mm diameter by 300mm long. Pilot drill in it, 17mm drill bit just to take some of the meat out. Go as deep as I can possibly go without starting to chew up into swarf and snag things up. You can see I'm using a little bit of spray lube there and some of the coolant off the machine, but I tend not to use a great deal like I would do normally because I've got no splash guard on this little machine, and just end up with a spray at this high speed of coolant just flying everywhere, which is obviously not very desirable. Fix weight down, and now we're going to go straight in with a 60mm drill bit. Again, if I was on one of the bigger machines here, I'd have just gone straight in with a 60 and probably just ploughed fully straight in on, but so I'm just using a hook there, pulling some of the swarf out of the way. I think we're still running at a fairly fast speed there, we're doing about 160 RPM. Now I'm boring out for the bearings. That's the biggest boring bar that I've got, which added to the fun of getting a nice tight tolerance on the bearings through chatter. So skim off the back there, even everything up nicely to our measurements, slap her on the milling machine. It's 4 hours setting up there, pretty much every single clamp in the shop. We didn't have a faceplate big enough, and I haven't got an actual dividing head, so we're using a rotary table on a 90-degree faceplate, and a little bit of clocking it in here, which again, like I say, took like 4 hours, because as you can just see out of shot there, that's me winding the wheel round manually, and as anyone that's used any of these knows, it's not a quick process, and they're not usually a nice easy process either. So we clocked that into 10 or 15, I should say 0.1, 0.15 of a millimetre, because I'm a metric man. There's a support that's being put under this end, which you can't see, you can just see the bolt for it there. We're using a 4-tipped face mill. We've split this into 14.4 degrees, which will give us the 10 flats. So here we are working out when they're going to just touch each other and look nice for the width of the spokes to butt up against. Rotate it 14.4 degrees, clamp it back down on the block, and we had a roughing cut and a face pass cut there, as you can see, quick skim through. Well, that's tapping drill size for M16, so 14.2, something like that, millimetres. Then we're drilling a slight clearance, or counter bore as it would be known, in the top there, just to aid location rather than trying to cross thread things when this hub's getting on for 3 metres up in the air. We're sort of fishing around to screw things into it. Quick wipe down, clean the hole out, and then we use a centre in our drill there whilst we're all on the same digits to locate the tap and make sure everything's nice and square. And so that's M16 standard. And you can see, rotate again 14.4 degrees, make sure we're picked up on the face, and we're just going to repeat that process 10 more times. That's going to give us all of our location mounts, our location holes for the main spokes to screw into. hang the old thread through it again, clean it up, which is a dream with it all being aluminium, as you can imagine. Unlock it, spin it round, pilot drill, in with the tapping size, swap that for our counter bore, stick the little 10mm counter bore in there, put the centre back in, drop the tap down, square her up, wait until we've got location and we can move that out the road, fire it through, and like I say, repeat that 10 times. So these bearings we want to be super free running, and as most people will know, your bearings are usually pre-packed full of grease, so nice bit of thinners in there, pick all the grease out, give them a good clean, give them a good blowing round, make sure everything's nice and free. Same for the other one. Little spin, much more free running as you can see there. I think they're all nice and dry. And here's our hub, ready to have the bearings put in. See, we left that thicker bit of wall thickness in the centre for the threads. Essentially that's only clearance on a 30mm shaft which is fitting through it. And there's a 72mm outside diameter bearing. Nice little tappy, because the press was completely buried by all the other stuff in the workshop at this point, so back to the old fashioned method with a copper hammer. Make sure everything's nice and free still, nothing's tightened up, bearings aren't too tight, and there we go, one hub. See, we've also noted the numbers on it at this point as well, so we can we know which spoke goes into which hole, and the reason for that will become more apparent later on. There we go, one hub ready to go. I hope you enjoyed the first part of our build series of Mouse's Marvellous mechanical medicine wheel. I'm proud to be finally being able to share some of this with you, and hope you enjoyed it. And we'll see you in the next part, which hopefully will be the making of the spokes. And as ever, it was a pleasure. Like, comment, question away, and subscribe if you want to see some more, because you just never know what's going down in the adventures of Mouse's garden.